Hello, welcome to my final project for the CS50 course Cybersecurity. Today is the 28th of December 2023 and my name is Patrick Brakel from Amsterdam, the Netherlands. My GitHub and EDX username is Patrick Brakel and is listed on the screen. For the final project, I chose an article published on the 14th of September 2023 by Jonuts Argheir. The article is called, Azure HD Insight Flaws Allowed Data Access, Session Hijacking, Payload Delivery. Throughout the cybersecurity course, we have seen various methods of gaining unwanted access to data or information. This article will further discuss the phenomenon of cross-site scripting. I chose this article because cross-site scripting is a topic I have seen before during the computer science course. The topic caught my attention even then, and so I thought it would be interesting to delve into it. Below is the schedule for this presentation. First, I will explain what Azure HD Insight is. Second, I will briefly talk about two different types of XSS. After which I will explain how Orca discovered the vulnerabilities. Then I will elaborate on one of the vulnerabilities and explain in detail how it was found. Finally, I will explain how the case ended and how to describe yourself against these vulnerabilities. Microsoft provides Azure HD Insights, an open-source analytics solution that is fully managed and scalable, capable of handling large data workloads in a flexible manner. It is essentially a cloud-based service that provides several data processing frameworks to make big data administration, processing, and analysis easier. HD Insight provides open-source frameworks for a variety of data processing activities, including Hadoop for batch processing in Apache, Apache Spark for processing data in memory, HBase on Apache for NoSQL data, Kafka and Apache Storm for real-time processing, and R-Server machine learning, R-Server. HD Insight is compatible with more Azure services, like Azure Blob Storage or Data Lake Storage for data management and archiving, Microsoft Power BI for visualization, Azure Synapse Analytics for warehousing, and Azure Data Factory for ETL operations. Cross-site scripting, XSS, is the process by which an attacker inserts malicious scripts onto a website that is trusted, which are then executed by unsuspecting browsers. This may result in data theft, unauthorized access, or even total system compromise. Two common types of XSS vulnerabilities are reflected XSS and stored XSS. Their execution mechanisms are the primary distinction between them. Reflected cross-site scripting, XSS. This kind of attack happens when a malicious script is added to a URL and is instantly mirrored back to the user, only executing for those who click on the specially created link. Stored cross-site scripting, XSS. This type of malicious script executes for any user accessing the compromised page after being saved on the server. The main distinction is in how it's delivered. Stored XSS affects every user who visits a website, whereas reflected XSS targets specific requests. Orca Security is a cybersecurity company renowned for its innovative cloud security platform. They are dedicated to using cutting-edge approaches and ongoing innovation to solve security challenges. Recently, 8 significant cross-site scripting, XSS, vulnerabilities were found by the Orca Research Pod on Azure HD Insight in a variety of Apache services. They discovered that the Apache Amberry background operations had multiple parameters that, by default, could be modified. After identifying this primary stored XSS vulnerability, they expanded their investigation. Leveraging hands-on manipulation combined with in-depth exploration of the text rendering engine, they were able to discover 8 XSS vulnerabilities in total, each of which required a unique approach to exploit. Using various techniques, they subsequently pinpointed 7 more similar vulnerabilities. These are shown in the table below. 2 of them were reflected XSS types, the other 6 were stored XSS. In the overview shown, the CVE identifiers are displayed. CVE stands for Common Vulnerabilities and Exposures. The identifiers are unique, standardized labels assigned to identify and track vulnerabilities in software and hardware systems. The purpose of CVE identifiers is to provide a common naming convention for publicly known security vulnerabilities. This standardization helps in communication, information sharing, and coordination among cybersecurity stakeholders, including vendors, researchers, and organizations. The first XSS that Orca found in Azure HD Insight was in Apache Amberi background operations, where they managed to modify default parameters by editing various values. Due to a special characters filter that was included in the dashboard, they weren't able to modify the background operations parameters directly to a malicious XSS payload, but they got round this by first modifying them to a valid value, and then resending the request via Burp Suite. Workflow. 1. Create a new HD Insight service on Azure Portal. 2. Select the interactive query cluster type and set the version. 3. Access the public endpoint of the service. Navigate to Services and select HDFS. 4. Click on the Run Service check option in Background Operations. 5. Inspect the request made during this process. Modify the request to inject a simple HTML. 6. Observe that the injected code is reflected and rendered. 7. Proceed to inject a stored XSS payload which will be subsequently executed. Orca promptly reported all vulnerabilities to Microsoft, which addressed them with the August 2023 Patch Tuesday security updates for Azure HD Insight. Collaboration between security firms and software providers is crucial in ensuring swift mitigation of potential threats. Even though these XSS vulnerabilities have now been fixed by Microsoft, it's still important to implement robust security practices to minimize the risk of further XSS vulnerabilities. There are several recommendations to protect against XSS. Input validation. Validate user inputs against expected formats, data types, and ranges. This mitigates the risk of script injection. Output encoding. Use output encoding, HTML, JavaScript, and URL encoding to ensure that user-generated data is properly sanitized before being displayed in web pages. Content Security Policy, CSP, implements CSP to add an extra layer of security that can restrict the execution of scripts and minimize the potential impact of any XSS vulnerabilities. Use frameworks and libraries. Utilize modern web frameworks and libraries that incorporate security features by default. These frameworks often include mechanisms to prevent XSS vulnerabilities, such as automatic output encoding. Apply the principle of least privilege. By giving users and processes only the permissions required for their specific tasks, you limit the potential attack surface for an attacker to exploit. This means that even if an attacker manages to inject malicious scripts through an XSS vulnerability, they will have limited access to sensitive data and functionality due to the principle of least privilege. As we conclude, it's crucial to extract insights from this incident. Prioritize robust input sanitization, foster collaboration with security researchers, and promptly apply patches. Cybersecurity is a collective responsibility, and heightened awareness is key to fortifying our defenses. In summary, comprehending and mitigating software vulnerabilities are pivotal in cybersecurity. Whether as developers or users, let's stay vigilant, adhere to best practices, and actively contribute to fostering a secure digital landscape. Thank you for your participation today.